Dear student, and welcome to Rare Shikshan Samstha Satara ROSE project for the year 2021 and 22 for 11th Science conducted by Yashwantrao Chauhan, Institute of Science, Satara. Myself, Mrs. Pawar Manisha Nitin from the Department of Juliet Mathematics. And today we start next topic from Mathematics section first, and name of the topic is Measures of Dispersion. Or in other words, you can say that statistics. So you are familiar with these measures of dispersion in your 10th standard, and you know up to mean, median, and mode. And in this topic, we start our next measures, which are range, variance, and standard deviation. So first we see what is mean by dispersion. So our first article is meaning and definition of measures of dispersion and range of the data. So first we start with definition or meaning of this dispersion. So dispersion refers to the variations of the items among themselves or around an average. So you simply remember this dispersion as it is around an average, or you can remember this dispersion as dispersion is a measure of the variation of atoms. So in simple words, you remember this as it is a measure of variation of atoms. Or another definition, the degree to which numerical data tend to spread about an average value is called variation or dispersion of the data. And these three measures are, first is range, second is variance, and third is standard deviation. So we start with range. So first we saw what is the definition of this range. It is the simplest measure of dispersion, and it is given by the difference between largest value and the smallest value. So here is the definition. It is defined as the difference between the largest and the smallest value. We denote this largest value by L and we denote the smallest value by S. So our formula becomes range is equal to L minus S. And we have to find this range in three types of data. And all of you know these three types of data are, first is raw data, second is ungrouped data, and third is grouped data. In raw data, we have given only observations, that is values of xi. In ungrouped data, we have values or observations with their frequencies. And in grouped data, our observations are grouped in their class intervals. So all of you know about these types of data. So we have to find this range, variance, and standard deviation in all these three types. First is our raw data, that is only observation. Second is ungrouped data, and third is grouped data. So this is our definition, that is range is equal to L minus S. And now before going to example, first we saw where we use this range. So these are uses. First is it is used in stock market, and second is it is used in calculation of mean temperature of a certain place. So remember these two uses. And now we see example related to this range. So here is our question. Following data gives weights of 10 students in kg in a certain school. Find the range. That is, here we have given weight of 10 students and which is in kg. And here our 10 observations, that is weight of the students. So this type of question carry 1 mark because we have to take only difference between two values. And so this type of question carry 1 mark. And this whole topic carry 5 marks in our annual exam question paper, which carry 80 marks. So in our 80 marks question paper, there are 5 marks for this statistics. And in this 5 marks, this range carry 1 mark because we have to take only difference. So first we find here largest value and smallest value. So if we observe this observation, here smallest value is 36 and largest value is 73. So first we write smallest value, which is denoted by S, largest value, which is denoted by L. And here we write these values, it is 36 and 73. And so this range becomes L minus S, that is 73 minus 36, it is 37. So here students, this is simplest question which carry 1 mark to find the range of the data. Then we see second examples related to our ungrouped data. That is, here we have given observations with frequency. So here is our observations with their frequency. So this score means our observations and this is our frequency. And all of you know this experiment, rolling a die. If we roll a die, all of you know that we get numbers from 1 to 6. So our observations are from 1 to 6. And if we throw or if we roll this die 25 times, then we get 1 4 times, we get 2 6 times. Similarly, we get 6 number 3 times. And so this total sum of frequency becomes 25. But we require only observation, not their frequency. So we consider the score. And in this score, our largest score is 6, smallest score is 1. And so our range becomes 6 minus 1, that is 5. So in your question paper, you write answer as 6 is the largest score, that is our L. L is the smallest score, that is our S. And so this range becomes 6 minus 1 is equal to 5. So first type is of raw data, that is only observation. Second type is ungrouped data, that is our observations are with their frequency. So remember the difference between given data. Now we see next example. Typing mistakes done by Radha during a week. So here our observation starts from 15, 20, 21, 12, 17 and 10. So here again the formula is same because we have only observation. So we find largest value and smallest value. Largest value is 21 and smallest value is 10. So range becomes 21 minus 10, that is 11. So we have to take only difference with their observations. Now last type, that is grouped data. That is our observations are in class intervals. And formula is our largest observation minus smallest observation. So we find our largest observation by using highest class. So this is highest class 70 to 72. And for largest value, we consider its highest limit. So highest limit becomes 72. So our L becomes 72 and our smallest value, that is lowest class in our lowest interval. Lowest interval, it is 62 to 64. So S becomes 62 and L becomes 72. So here first we write these values. So L is upper limit of highest class. So it is 72. S is lower limit of lowest class. So it is 62. And so our range becomes L minus S, that is 72 minus 62, it is 10. So remember how we find range in grouped data. In grouped data, our observations are with their class interval. So we find highest class interval and lowest class interval. And for S, we choose lowest limit or lower limit of lowest class. And for L, we consider upper limit of highest class. So remember this first measure of dispersion, that is range, which is very simple and which carry 1 mark in our question paper, that is very short answer question. And now we have to proceed to our next measure, that is variance and standard deviation. And this type of question which carry 3 or 4 marks in our question paper. So our next measure is variance and standard deviation. And first we read this need of variance and standard deviation, that is drawback of range. So the main drawback of the range is that it is based on only 2 values and does not consider all the observation. Because in our 4 examples we saw, we consider only largest observation and smallest observation, not all observation. So we consider only 2 values. And so to overcome this drawback, we consider our next measures, that is variance and standard deviation. So this variance and standard deviation overcome this drawback as they are based on the deviation taken from the mean. So our definition is variance is the variance of a variable x is defined as the arithmetic mean of the squares of all deviation of x taken from its arithmetic mean. So all of you familiar with arithmetic mean? What is mean by arithmetic mean? It is the sum of observation, the sum of all observations divided by number of observations. So for variance, what we consider here? Arithmetic mean of squares of all deviations of x taken from its arithmetic mean. We denote arithmetic mean of observation by x bar, and we denote this variance of variable x by VAR, and into bracket we write our variable x, or we use symbolic form sigma square. So our formula becomes variance of x is equal to sigma square. It is arithmetic mean of deviations of x taken from its arithmetic mean. So it is xi minus x bar square. We take its sum and we divide this whole sum by number of observations. So remember this formula for variance and its definition. It is arithmetic mean of the squares of all deviations of x taken from its arithmetic mean. Now we find standard deviation. It is nothing but the square root, or you can say that positive square root of variance. And we denote the standard deviation by sigma, or square root of variance of x. So standard deviation is defined as positive square root of the variance. Because generally we take square root as plus or minus, but here for standard deviation we consider only positive square root. So only one value. Now before going to example, first we write these formulae for our raw data, ungrouped data, and grouped data. So first we write formula for raw data. That is only observations are given. So here we consider our variable x with observations x1, x2 up to xm. And x bar be its arithmetic mean. All of you familiar with this x bar, and all of you know that how we find this x bar. So this x bar is equal to summation of xi upon n. So here we write formula for this arithmetic mean as, so we circle this formula so that we remember this result. So here is our formula for arithmetic mean. It is 1 upon n summation of xi, I from 1 to n. And so we take deviation, square of deviations of variable x taken from its arithmetic mean. So here is our variable xi, here is our arithmetic mean x bar. And so our formula becomes variance of x is equal to sigma square, that is 1 upon n, summation of xi minus x bar square, I from 1 to n. Instead of this first result, you can remember this variance of x in another way as 1 upon n summation of xi square, I from 1 to n minus x bar square. So you remember this formula in these two ways. So it depends on your observations. If our observations are simple, then you take or you can use this first result. If your observations are large, then you can use the second result or first result. It depends on you. तुम्हाला जसं सोयीचं वाटेल तशा पद्धतीने तुम्ही फॉर्म्युला चूज करू शकता, एक तर पहिला किंवा दुसरा. हा असेल आपला रॉ डाटासाठी. आता आपण कन्सिडर करतोय अनग्रुप्ड डाटा, दॅट इज अवर ऑब्झर्वेशन्स आर विथ फ्रिक्वेन्सी. So if you remember this first result, by using this first result, you remember your second result also. Because our observations are with their frequency, so we take observations with frequencies as, so we write our next result. For ungrouped data, that is here our observations are with their frequency. So x1, x2, xn with f1, f2, fn. So variance of x is defined as 1 upon n summation fi into xi minus x bar square. And in other words or another result, it is 1 upon n summation of fi xi square minus x bar square. So जिकडं जिकडं तुमचं xi होतं त्याच्या जोडीला आपण काय घेतोय fi, आणि जिथं तुमचा स्मॉल n होता तिथं आपण काय घेतोय तर कॅपिटल n. एवढाच चेंज करायचा आहे. जर तुमच्या लक्षात पहिला फॉर्म्युला राहत असेल तर दुसरा त्याच्यावरून लक्षात ठेवायला काही हरकत नाहीये. जिथं जिथं तुम्हाला xi दिसेल तिथं तिथं तुम्ही fi जोडणार आहात आणि स्मॉल एनच्या जागेवर कॅपिटल एन, एवढाच चेंज आहे. आता कॅपिटल एन म्हणजे काय असेल, इट इज टोटल फ्रिक्वेन्सी, दॅट इज समेशन ऑफ fi. सो रिमेंबर दिस रिझल्ट. Capital N means summation of fi. So You have to remember this capital N, that is total frequency. Then here we find our X bar. Again we use same method, that is we carry this xi with fi. जर रॉ डाटा मध्ये फक्त xi होतं तर तुम्ही फक्त xi ची सम घेतली. आता xi बरोबर fi आहे तर तुम्हाला तिथं fi जोडायचंय. जसं मी मगाशी म्हटलं तसं की तुमचं जिकडे जिकडे xi असेल तिथं तिथं fi येईल. सो x बारचा फॉर्म्युला काय झाला, समेशन ऑफ fi xi I फ्रॉम 1 to n अपॉन कॅपिटल N. सो स्मॉल n रिप्लेस कराल कॅपिटल N नी आणि जिकडे तुमचं xi असेल त्याच्या जोडीला तुम्ही काय घ्याल fi. एवढाच चेंज असेल. बाकी पहिला फॉर्म्युला लक्षात असेल तर दुसरा फॉर्म्युला लक्षात ठेवायला काही प्रॉब्लेम येणार नाही. सेम रिझल्ट असेल तुमचा ग्रुप्ड डाटासाठी. फक्त ग्रुप्ड डाटासाठी तुम्हाला ऑब्झर्वेशन क्लास इंटरवल मध्ये असतील. आपण क्लास इंटरवल घेऊ शकत नाही म्हणून आपण त्या क्लास इंटरवलची काय घेणार आहोत, मिड व्हॅल्यू. एवढाच चेंज असेल, बाकी तुमचा फॉर्म्युला सेम आहे. सो आपला नेक्स्ट फॉर्म्युला बघूया ग्रुप्ड डाटासाठी. x1, x2, xn be the midpoints. एवढाच change of the intervals. So suppose our interval is from 10 to 20, then its mid value becomes 10 plus 20 upon 2, that is 15. So our x1 is 15. So class interval असतील, ग्रुप डाटा असेल तर तुम्हाला एक कॉलम एक्स्ट्रा करायचा आहे, that is mid value or midpoint. बाकी फॉर्म्युला तुमचा सेम आहे जो अनग्रुप्ड डाटाला होता तो. वाटल्यास तर आपण एक स्लाइड परत मागे जाऊन बघूया अनग्रुप्ड डाटासाठीची. सेम रिझल्ट आहे, फक्त आपण इथं काय म्हटलं होतं, x1, x2, xn बी द व्हॅल्यूज ऑफ द व्हेरिएबल x. आणि इकडे काय म्हणतोय आपण, तर x1, x2, xn बी द मिड पॉइंट्स. येतोय का लक्षात डिफरन्स बघा. फक्त ज्याला कॅल्क्युलेशन फार आवडतायत, ज्याला बेरीज वजाबाकी गुणाकार भागाकार खूप आवडतोय करायला, त्याच्यासाठी सगळ्यात इंटरेस्टिंग टॉपिक असेल. फक्त आपल्याला कॅल्क्युलेशन करायचंय, फॉर्म्युला एकच लक्षात ठेवायचा. जो कसा लक्षात ठेवायचा तुम्हाला सांगितलंय. पहिला लक्षात ठेवायचा फक्त ऑब्झर्वेशनचा आणि अनग्रुपडेला आणि ग्रुपडेला फक्त त्याच्याबरोबर फ्रिक्वेन्सी जोडायची आहे आणि स्मॉल एन रिप्लेस करायचे कॅपिटल एन. सो आता ह्या तीनही टाईप्स जे आहेत आपले रॉ डाटा, अनग्रुपड आणि ग्रुपड, त्याच्यावर आपल्याला एक्झाम्पल्स पाहिजे. सो वी स्टार्ट विथ अवर फर्स्ट एक्झाम्पल. So compute variance and standard deviation of the data, or you can say for the following observations, and here we have given 7 observations. So this type of question carry 3 marks in our question paper because it is a raw data, only observations, not their frequency. So this is of the type raw data. So तुमच्याकडे दोन टाइप आहेत फॉर्म्युल्यांचे. पहिला xi मायनस x बार स्क्वेअरचा, किंवा तुम्ही दुसरा घेऊ शकताय 1 अपॉन n xi स्क्वेअर मायनस x बार स्क्वेअर. सो आपण पहिल्या रिझल्ट न जर गेलो तर आपल्याला टेबल तयार करण्यासाठी पहिला कॉलम कसा कोणाचा असेल, xi चा, आणि दुसऱ्या कॉलम मध्ये आपल्याला पहिल्यांदा डिफरन्स घ्यावा लागेल xi मायनस x बार आणि मग स्क्वेअर. सो हिअर इज अवर टेबल. फर्स्ट कॉलम इज ऑफ xi, सेकंड इज xi मायनस x बार, and third is xi minus x bar bracket square. एक्झाम्पल सोडवताना सगळ्यात पहिल्यांदा साईडला फॉर्म्युला लिहून ठेवा आधी आणि मग कॉलम्स तयार केले तरी चालतील जर लक्षात आलं नाही तर. अदरवाईज तुम्ही पहिल्यांदा कॉलम करा, त्याच्यामध्ये व्हॅल्यूज एंटर करा, मग फॉर्म्युल्याकडे गेलात तरी चालेल. आणखी दुसरी महत्वाची गोष्ट, तुम्हाला प्रत्येक जो कॉलम आहे त्याची सम लागणारच असं नाहीये. आता ह्या एक्झाम्पल आपल्याला सम कोणाची लागणार आहे, तर मीन काढण्यासाठी xi ची लागेल, व्हेरियन्स काढण्यासाठी xi मायनस x बार स्क्वेअर ची सम लागणार आहे, पण xi मायनस x बार ची सम आपल्याला लागणार नाही. सो इथं आपण काय करणार आहोत, तर डॅश करणार आहोत. ज्याची गरज नाही त्याच्या समस आपण करणार नाही. सो सगळ्यात पहिल्यांदा टेबल मध्ये कॉलम करा, ज्याची टोटल लागणार आहे त्या टोटल फक्त लिहा, बाकीच्या ठिकाणी आपण डॅश करणार आहोत. म्हणजे इथं आपल्याला काय करायचं, तर डॅश करायचं. आपल्याला ही सम नको आहे. सो हे लक्षात ठेवून करायचंय, कारण हे एकतर कॅल्क्युलेशनचं एक्झाम्पल आहे, खूप वेळ आपला जाणार आहे आणि तेवढा वेळ आपल्याला घालवायचा नाही, कारण आपल्याला 80 मार्काचा पेपर 3 तासात सोडवायचा आहे आणि तेवढी वेळेची बचत आपल्याला आपली आपण करायची आहे. आणि आणखी एक दुसरी महत्वाची सूचना मी सांगेन, तुम्हाला ह्या ज्या बेरजा करायच्या त्या तुम्ही इथंच करणार आहात. पुन्हा मागच्या पानावर जायचं, सगळे नंबर लिहायचे, पुन्हा बेरीज करायची, डबल वेळ घालवायचा नाही. म्हणून लिहितानाच तुम्ही हे नंबर्स कसे लिहाल, हा एक अंकी नंबर आहे, सो 9 आलं, खाली 12 आहे, 12 लिहिताना तुम्ही बरोबर 9च्या खाली त्याचा युनिट प्लेस आलं पाहिजे असं लिहाल. 9 च्या खाली 2 येईल, बाजूला 1 येईल. पुन्हा 15 बरोबर 2 च्या खाली 5 आलं पाहिजे, 1 च्या खाली 1 आलं पाहिजे, जेणेकरून ही उभी बेरीज तुम्हाला इथंच करता येईल. सिमिलरली इकडे सुद्धा 81, 36. आता हा जो 9 आहे तो कुठे पाहिजे, तर बरोबर 6 च्या खाली, आणि 10 प्लेसच्या जागेवर तुम्ही 0 लिहाल. इथं 2 0, इथं 0 9, एका खाली एक बरोबर त्या सम तुम्ही करण्यासाठी ते नंबर्स लिहा, जेणेकरून तुमची बेरीज इथंच व्हायला पाहिजे. पुन्हा मागच्या पानावर इकडं डबल कॅल्क्युलेशन, डबल नंबर लिहायची गरज पडून देऊ नका. अशा पद्धतीने ती बेरीज इकडंच करा की आपला वेळ वाचेल. राहील लक्षात सगळ्यांच्या की तुम्ही कशा पद्धतीने हे टेबल लिहिणार आहात, व्हॅल्यूज लिहिणार आहात. So these are our 3 columns, and now we write these observation. First is 9, 12, 15, 18, 21, 24, 27, and this sum becomes 126. Then we find arithmetic mean, and arithmetic mean is given by 1 upon n summation of xi, and so we find this result, or we find this mean. So first we write number of observations, which are 7. Then we find x bar, which is summation of xi upon n. इथं करेक्शन आहे पहा, हे x1 नाहीये, इथं काय घ्यायचंय आपल्याला, xi घ्यायचं, x1 नाही. सो एवढी करेक्शन करायचं, summation xi upon n, and this summation xi, here we take this summation, it is 126. So 126 upon 7, this becomes 18. So this arithmetic mean is equal to 126 upon 7, that is 18. And here we use this arithmetic mean 18 to find this difference xi minus x bar. So first difference becomes 9 minus 18 minus 9, 12 minus 18 minus 6, 15 minus 18, it is minus 3, 18 minus 18, 0, 21 minus 18 plus 3, 24 minus 18 plus 6, and 27 minus 18, it is plus 9. Here we doesn't require this sum, so we proceed to our next column, that is we take their squares. So minus 9 square, it is 81, minus 6 square, it is 36, and similarly we take squares of remaining numbers, and then we write it's a sum. So its sum becomes 252. And so we write in our formula variance of x, which is also denoted by sigma square, and it is 1 upon n summation of xi minus x bar square, I from 1 to n. And so we substitute here 252, this summation, total number of observations are 7, and this division becomes 36, and which is our variance, that is sigma square 36. And now we take its square root to find standard deviation, which is denoted by SD, which is also known as sigma, and square root of 36, it is 6. So our table carries 1 mark, our variance is equal to 36, carries 1 mark, and our standard deviation carries 1 mark, and this is our 3 marks question in our question paper. So this is about variance and standard deviation for raw data. So this is about our first lecture. In our next lecture, we saw remaining examples related to our ungrouped data and grouped data. So thank you.